Okay, let's picture this. Try to imagine North America, about 13,000 years ago. It's almost like a mythic time, right?
Definitely.
You got these vast herds of woolly mammoths, mastodons, just huge animals roaming around.
Colossal, really.
And alongside them, you have this unique human culture, the Clovis people. Really ingenious, known for these amazing, distinctive spear points.
Beautifully made, yeah.
A thriving world.
Exactly, a vibrant world. And then, poof, seemingly overnight, it just changes dramatically.
Gone, or largely gone.
The whole era, these incredible creatures, this pioneering culture, what on earth could cause something like that? So suddenly, so widespread.
That's the million-dollar question, isn't it?
So today on the Deep Dive, we're digging into exactly that. We're looking at some new, really compelling evidence that might finally crack this ancient mystery. We're talking about the Younger Dryas impact hypothesis. The basic idea is that some kind of cosmic event radically reshaped Earth, especially North America, almost 13,000 years ago.
A major turning point. Right. And our mission today is to kind of synthesize the latest science, especially this really big new study. It's from UC Santa Barbara, Professor Emeritus James Kennett and his team.
Yeah.
Published in PLOS One.
Peer-reviewed. Important to note.
Absolutely. This isn't fringe stuff. It's serious science, and some are calling this new evidence the creme de la creme, the best proof yet. So we'll look at what they think happened, where, and, why it actually matters.
It really is such a fascinating moment because things change so incredibly fast. You painted the scene, North America, 12,800 years ago, teeming with megafauna.
Yeah, not just mammoths, right?
Oh, no. Mastodons, giant ground sloths, camels, saber-toothed cats. I mean, over 70% of 35 genera of these big animals. Widespread.
Wow.
And yeah, the Clovis culture alongside them. Highly skilled hunters, their fluted points are unmistakable in the archaeological record, a major human presence.
Okay, so what's the core mystery then?
Well, it's the timing, the sheer synchronicity of three massive things happening, boom, right at the same time.
Okay, what are they?
First, like you said, the extinction. Most North American megafauna wiped out. Now, some woolly mammoths survived for a bit longer on isolated islands like Wrangel Island, but continent-wide. Devastation.
Okay, that's huge. Number two.
The Clovis culture vanishes. Their distinctive tools, their technology, it just disappears from the archaeological record. Gone.
Just like that.
Pretty much. And third, the climate takes a nosedive. Suddenly, we plunge into the Younger Dryas cool period, a 1,000-year return to near Ice Age conditions.
But wasn't the Earth generally warming up then?
Exactly. That's what's so weird. It's this sharp cold snap right in the middle of a warming trend. So you have mass extinction, cultural disappearance, and sudden climate change all hitting at the exact same time.
That cannot be a coincidence.
That's what scientists have thought for decades.
Yeah.
It's led to all sorts of ideas. Maybe humans overhunted the animals, maybe climate change alone did it.
Right.
But the Younger Dryas impact hypothesis, the YDIH, it offers one potential explanation that links all three. A single massive cause.
And that single cause sounds like something out of a disaster movie. A fragmented comet hitting the atmosphere.
Well, yeah, the theory is a large comet, maybe over 100 kilometers wide, brink up as it entered the atmosphere.
So not one big impact like the dinosaur killer.
Probably not. More like multiple explosions happening above the Earth's surface, sending down shock waves, maybe fragments, and just intense heat across huge areas.
James Kennett, one of the lead researchers, he said all hell broke loose. That really paints a picture.
It absolutely does. The YDIH suggests this triggered an impact winter. Think about it. Massive wildfires ignited across continents.
Okay.
That produces huge amounts of smoke, soot. Combine that with dust kicked up by the airbursts. It creates this thick blanket in the atmosphere.
Blocking out the sun?
Exactly, leading to rapid global cooling. Plus, you might get rapid melting of ice sheets near the impact zones, which could, paradoxically, contribute to more localized cooling through freshwater pulses into the oceans.
So those harsh conditions, the cold, the dark, the disrupted environment, that's what potentially led to the megafauna dying off and the Clovis culture collapsing.
That's the proposed link, yes. A major contributing factor, perhaps the major factor. It really underscores how vulnerable life can be to these external cosmic events.
Okay, so proving something like that happened 13,000 years ago, that sounds incredibly difficult. How do they do it? What's this new creme de la creme evidence?
Right. The big new finding is shocked quartz. They found it at 3 really important classic Clovis archaeological sites.
Shocked quartz. Okay, layman's terms, what is that?
It's basically grains of sand quartz that have been physically altered on a microscopic level by unbelievable pressure and heat.
More than like earthquakes or volcanoes?
Oh, way beyond that. Forces that you really only get from a cosmic impact. It leaves a unique fingerprint inside the crystal structure of the quartz.
And why is that the game changer? Especially if there's no big crater.
Because it's considered a definitive proxy for impact, particularly for these airburst events that might not leave a big, obvious crater. The internal damage and, crucially, signs of melting within the quartz that can only happen under those extreme impact conditions.
Okay, so where did they find this?
The study looked at 3 really key locations: Murray Springs in Arizona,
Okay.
Blackwater Draw in New Mexico,
Right.
and Arlington Canyon, which is out on California's Channel Islands.
And these aren't just random places?
Not at all. These are foundational sites for understanding early humans and megafauna in North America, the places where the Clovis mystery really began. And they use some serious high-tech methods, electron microscopy.
Like looking really, really close.
Exactly. Peering right into the quartz grains to confirm these tiny glass-filled fractures, features that just don't form through normal Earth processes. It has to be an impact.
Okay, this is where you said it gets really interesting. They found specific types of features in the quartz, not just the standard ones.
Yeah, that's right. They found the classic features called planar deformation features, or PDFs, but also these other ones described as subplanar, subparallel.
And what makes those so special?
The absolute clincher is finding melted silica, basically glass, within these tiny fracture networks inside the quartz grains.
Melted.
Melted. Think about it. Regular geological forces, like tectonic stress, can crack rocks, sure, but they don't generate the kind of intense, instantaneous heat needed to actually melt silica inside those cracks.
I see.
The analysis showed these fillings were glassy, amorphous, meaning the quartz literally melted and then cooled incredibly quickly. That requires the extreme temperatures and pressures you only get in an impact. It's not just a crack, it's evidence of melting caused by the shock.
Okay, so the shocked quartz is like finding the bullet casing, basically. But it's not the only piece of evidence, right? There's a bigger picture here.
Absolutely. The shocked quartz is a huge piece, maybe the most definitive piece, but it fits into a larger puzzle scientists have been assembling.
Like this black mat layer I've heard about.
Exactly. At many, many sites across North America and even into Europe, right at this specific time boundary, the Younger Dryas boundary, or YDB, you find this distinct dark layer.
What is it?
It's rich in carbon, basically soot and charcoal. It's strong evidence for widespread, intense wildfires happening right around 12,800 years ago.
Okay, widespread fires. What else?
Well, within that black mat and the YDB layer generally, there's a whole suite of other unusual materials, these impact proxies, things that also point to extreme conditions.
Like what?
Unusually high levels of elements like platinum and iridium. These are rare on Earth's surface, but much more common in asteroids and comets.
Ah, okay, an extraterrestrial signature.
Precisely. Also things like nanodiamonds, microscopic diamonds formed under incredible pressure, and metallic spherules, tiny little balls of metal that melted and then cooled, plus bits of melt glass.
So lots of different indicators of high heat and pressure.
Exactly, and here's the key point. While you might be able to explain one of these things in isolation, like maybe platinum from a volcano, though that's debated finding the entire collection together,
Yeah.
that specific combination of proxies, it's only ever been found in association with known cosmic impact events, not volcanic eruptions, not earthquakes, nothing else.
And they found this whole suite at many places.
At over 60 sites now, across 5 continents, all dating to that Younger Dryas boundary. The pattern is just incredibly strong. It points towards a widespread, simultaneous event.
Which brings us back to timing. Synchronicity, you called it.
Oh.
How sure are they that all this happened at the exact same time across such vast distances?
That's absolutely crucial. And the dating methods have gotten really sophisticated. They use techniques like Bayesian analysis on the radiocarbon dates
Okay.
and statistical tests like chi-squared tests. These consistently show that the YDB layer with all these proxies dates to the same narrow window right around 12,800 years ago across sites sometimes 1,500 kilometers apart.
So statistically, the dates are indistinguishable.
Within the margins of error for dating, yes. It strongly supports the idea of a single continent-wide synchronous event. All these different lines of evidence point to the same moment in time.
Okay, let's make this real. Let's look at the specific sites where they found the shocked quartz. They tell the story, don't they? Starting with Blackwater Draw in New Mexico.
Okay.
It's a famous one.
Hugely important. It's the type site for the Clovis culture where their artifacts were first properly identified, and the pattern there is stark.
How so?
You find Clovis points, you find mammoth bones, below that black mat, below the YDB layer, but never above it.
Never.
Never. And get this. They found a butchered mammoth skeleton right at that boundary, and it was stained black by the overlying mat.
Wow. So it was killed literally right before the event.
It strongly suggests that, yes. And after that layer, there seems to be a gap in human occupation at the site. Maybe several hundred years where people just weren't there. A real disruption.
A gap of hundreds of years. Wow.
Okay.
What about Murray Springs in Arizona?
I think we're not.
Other big Clovis site.
Same story, different location, just as compelling. Megafauna, Clovis, artifacts, all below the black mat from 12,800 years ago. Nothing above.
Any specific finds there?
Again, a butchered mammoth skeleton found with Clovis points among the bones, also stained black by that mat, like a snapshot frozen in time.
Incredible.
And maybe even more evocative, they found hundreds of mammoth footprints preserved because they were rapidly buried by the sediments of that black mat layer right after the YDB event.
Footprints preserved by the catastrophe itself.
Exactly. And at Murray Springs, too, evidence suggests a gap in human presence afterwards. Maybe 500, maybe even up to 1,400 years. A long time. It just shows how fragile things were, how quickly everything changed.
And the third site, Arlington Canyon. That's different. It's on an island.
Right, on the Channel Islands off California, which gives us a unique perspective away from the mainland dynamics.
What did they find there?
Well, ancient human remains, known as Arlington Man, dating to that Clovis era, were found below the black mat. And critically, the islands had their own unique megafauna pygmy mammoths.
The smaller ones.
Yeah. And they also went extinct right around 12,800 years ago, synchronous with the mainland extinctions.
And humans on the island.
Same pattern. There appears to be a gap of maybe 600 to 800 years between Arlington Man and the next evidence of people on the island.
So, mainland kill sites, isolated islands. The pattern holds.
It really does. The consistency across such different environments is what makes the impact hypothesis so compelling. It raises that huge question. How does one single event wreak such havoc so synchronously across a whole continent, hitting ecosystems and human cultures?
Now, any big idea like this, especially one suggesting such a dramatic event, is going to face pushback. Science works through debate and skepticism.
Absolutely. And the YDIH has definitely had its share of controversy over the years. That's healthy.
So what were some of the main criticisms, and how does this new research address them?
Well, for example, some early studies failed to find peaks in microspheral concentrations at certain sites. Microspherals are tiny glassy or metallic beads, another impact proxy. But later work showed that this was often because the original sampling was too coarse, or they weren't using the right techniques, like scanning electron microscopy, to actually find and identify these tiny things. When researchers went back and looked more carefully, the peaks were there.
So, better methods found the evidence. What else?
There was an argument about some carbon spherules suggesting they might just be like fungal spores or insect droppings, something biological.
Right, not impact related.
But that was countered pretty strongly. First, they found nanodiamonds inside some of these spherules. You don't get nanodiamonds from fungi. And second, similar spherules were found in Greenland ice cores dating to the YDB. Fungal spores are unlikely there.
Makes sense. Any other major points of debate?
Nanodiamonds themselves were debated claims of misidentification. But again, multiple independent studies have now confirmed peaks in specific types of nanodiamonds in YDB layers far apart, like Belgium and Oklahoma. And the dating, some argued the sites weren't truly synchronous.
Which we already covered, right?
Exactly. The rigorous Bayesian analysis and statistical tests consistently show the dates line up across the continent within the dating uncertainties. So each major criticism has really been met with more data, better analysis, and refined techniques.
Okay, so we have this mountain of evidence, shock quartz, the black mat, platinum, iridium, nanodiamond spherules. But still, that question lingers for many. Where's the giant crater? If it was so big, shouldn't there be a massive hole somewhere like Chicxulub?
That's a perfectly fair question. And the answer lies in the type of impact event proposed. It likely wasn't a single solid asteroid hitting the ground like Chicxulub.
Right, the fragmented comet idea.
Exactly. The theory involves touchdown airbursts, the comet breaks up, and pieces explode in the lower atmosphere, maybe even hitting the surface, but not necessarily excavating one giant crater. The energy gets dispersed over a wider area.
But can an airburst really generate enough pressure and heat to make shocked quartz?
That's where the modeling comes in. The research team used sophisticated computer simulations hydrocode modeling. They modeled what happens when, say, a 100-meter comet fragment explodes at low altitude.
And what did the models show?
They showed pressures reaching up to 10 gigapascals, that's an immense amount of pressure, and temperatures soaring over 30,000 Kelvin.
Hotter than the sun's surface, you said.
Hotter than the sun's surface. And yes, those conditions are sufficient to create the glass-filled shocked quartz they found and to melt surface sediments, even without forming a single massive crater.
Okay, but don't most things burn up completely in the atmosphere?
No.
Is it realistic for fragments to even reach low altitudes or the surface?
That's a common perception, but fragmentation and fragments reaching the surface from airbursts are actually, well, pretty common. We have direct recent examples.
Like what?
Chelyabinsk, Russia, 2013. That was a big airburst, nearly 30 kilometers up, but it still showered the ground with fragments. One piece over 500 kilograms punched a hole in a frozen lake.
Wow.
Or Tagish Lake in Canada, 2000. Another airburst produced something like 10,000 fragments over a huge area. And older events too, Cicodia in Russia in 47, Campagasiello in Argentina. These meteorite falls created multiple craters and spread fragments widely.
So airbursts dropping fragments, even causing smaller craters or surface effects, it's a known phenomenon.
It absolutely is. These examples show that low-altitude touchdown airbursts can generate the required conditions for shocked quartz and the other proxies, explaining the evidence without needing one giant, easily identifiable crater. It changes how we think about impact risks and effects.
This whole body of research culminating in this shocked quartz evidence, it just paints such a compelling and frankly dramatic picture, a single cosmic event connecting climate, ecosystems, human culture.
It really ties it all together, doesn't it? The sudden climate shift, the collapse of those magnificent megafauna, the disruption of the Clovis people, linking them all back to this.
Yeah, Earth's systems aren't isolated. And cosmic events can be powerful agents of change.
Exactly. This research gives us an incredibly detailed snapshot of a truly pivotal moment in our planet's recent past. It's a stark reminder of how sudden and profound these external forces can be, reshaping life on Earth in the blink of an eye, geologically speaking.
It's more than just solving an old puzzle.
Much more. It fundamentally reframes our understanding of why those synchronous extinctions and cultural shifts happen when they did. The evidence, especially this shocked quartz conformation at key archaeological sites, makes the impact hypothesis incredibly difficult to ignore.
And it definitely leaves you thinking. As we wrap up this deep dive, you have to wonder, right? What other evidence of past cosmic impacts might still be hidden? Buried layers, subtle clues waiting for the right technology, or just dedicated scientists to uncover their stories?
It's a tantalizing thought. What other chapters of Earth's history might have been written by events from space?